Alright, so with this question here, right, the train is at traffic lights red and then it accelerates, doesn't it, okay, from rest. And we're asked in part A to calculate the magnitude of this acceleration. Okay, we haven't got a velocity time graph, so my thinking is just use the equations of motion, alright, and because we know it starts from rest, we can say, look, u is 0, alright, and then it says accelerates the constant rate for 60 seconds. So we know the time period then is 60 seconds until it reaches a speed of 45 meters per second. Okay, so there we've got sort of like a passage of time of 60 seconds where it goes from rest to a velocity of 45 seconds. And we can use the equations of motion over that time now. And we want to get the acceleration. So, you know, when you've got u, t and v connected and you want to work out a, we use the simplest of ones, v equals u plus at. Okay, so we put the numbers in, 45 for v, initial velocity was 0, plus a times our time, which is 60. Okay, so we've got that equation set up, that's 0, so it disappears. So then to get a, of course, you times in here, so take it over and divide. Okay, to get a, so then a will be 0.75 meters per second squared. Okay, 3/4 was 0.75, put it as a decimal. So that's the acceleration of the train. Then it says part 2 then, okay, so that's part 1. Part 2 then, it says find the length of time for which the train is decelerating. So we move on sort of in the story, okay, and it sort of travels, isn't it, for 16 minutes at this constant speed of 45 meters per second. And then it starts to slow down, it starts to decelerate. So think about the situation. This train has been travelling at a constant speed for a whole 16 minutes. Okay, so what's its speed when it starts to slow down? Well, of course, it's travelling at 45 meters per second, isn't it? So in this situation now, just before it's decelerating, its initial velocity is 45, okay, and then it starts to decelerate, okay, and it says, isn't it, at a rate of 0.25. Now, because it's decelerating, you need to sort of note that by putting negative in. Negative shows that it's decelerating. Okay, and then it comes to a stop at its destination B, so its final velocity will be 0, and we want to work out the time. Okay, now you've got similar situation set up as before. We can use v equals u plus at for this final sort of phase, the final phase where it's slowing down. Okay, so when it starts to slow down, don't forget the initial velocity, it was going at 45 meters per second. Okay, starts to slow down to a final velocity when it reaches the station of 0. Plus then a, right? Now a in this case is negative, 0.25, and of course then times the time which we want to work out. So a little bit of maths here, maybe take that over the other side, and then of course then divide by the 0.25. So you get your time, so you can use a calculator to make sure you get this right, and you get 180 seconds. Okay, so let's just read the question again to make sure. It says length of time for which the train is decelerating, and it is decelerating for 180 seconds.